Well, climate and climate change is in front of us almost every day in the news, and appropriately so. It's arguably the issue of our times, and it's great for me on MSU Today to catch up with Jeff Andresen. He's a professor in the Geography department. Actually, it's Geography. Tell me the title, Jeff.
It is. We have a very special title: Geography, Environment, and Spatial Sciences.
I wanted to get that right. And Jeff focuses on climatology and meteorology and a lot of things, and particularly sometimes climate change's impact on the Great Lakes and our agriculture, and it's just good to catch up with them to kind of get an assessment on climate and where we are. So, Jeff, welcome back to MSU Today.
Well, thanks, Russ. It's great to be back. It's been a little while.
Let's start with what is the difference between climate and weather, if you could start with that.
Well, they're closely related, and basically it's an issue really of time and perspective. Both of them deal with variables like air temperature or precipitation or wind speed, but in different time contexts. Weather and meteorology, for that matter, are linked with shorter time frames, milliseconds, hours, days. And climate, on the other hand, same variables but longer time frames, typically multiple years, typically decades or even longer periods.
And Jeff, you're also the state climatologist for the state of Michigan. What does that mean? What do you do in that role?
It is the state climatology program here, and it has a long history, but it basically is an entity here within the state of Michigan where we collect, analyze, and archive climate data going back to the beginning, and really specialize in the state of Michigan. And we provide information and expertise and data, of course, to the public and people who need or want climate-related information, and that ranges from an insurance claim and conditions for that to looking ahead in the future and infrastructure needs and design characteristics. There's all sorts of different questions we get about climate. But again, in general, it's an outreach-oriented organization attempting to provide quality climate information to the public.
So, Jeff, I know we could have an entire summit on this question I'm about to ask you, and they just actually recently did at the United Nations. There's a big summit coming up in Scotland in November, but where are we? Regionally, kind of nationally and internationally, because I know you said the impacts can vary by regions, but just assess the climate for us right now.
Well, it's one thing is unequivocal. That's the word that's used by the Intergovernmental Panel on Climate Change, and the world's getting warmer. Michigan and the Great Lakes are also getting warmer. And another one here that's just as, or you might even consider to be even more significant, it's getting wetter here locally. And that's more of a regional trend. And regional differences, there are regional differences around the world, but globally temperatures have warmed up a little over 1 degree Celsius, so a couple degrees Fahrenheit over the last century or so. It's a rapid increase relative to what we know about the Earth's geologic history, and probably the warmest right now, the last decade, is the warmest that we've seen, and certainly over at least 100,000 years, based on other information. So the world is getting warmer. There's all sorts of other variables related to that. The ice is melting, the sea levels are increasing, and all of these things are consistent once again with a warmer world. And that's true here in the upper Midwest and the Great Lakes region too.
And so what are some of the impacts of that warming?
Well, it varies. What we are seeing here in Michigan specifically, we've gained about 2 degrees Fahrenheit over the last 30 to 40 years, but it's important. There have been some seasonal differences, and there's been more warming in the cool season, especially during the winter season. That's warmed more than the summer. The other interesting thing is that our nighttime temperatures have warmed more quickly than our daytime temperatures. So the difference between the two, the diurnal range, it's called, is shrinking or decreasing with time, and that's something we see in other parts of the world. We think that the primary reason for that is an increase also in humidity. So there's more water vapor there, and we don't cool off quite as much at night as we have in the past. But given all that, again, collectively, there has been a little bit of a leveling off over the last decade or 15 years. There's been a lot of variability around a mean, but we're still, again, about 2 degrees warmer on average now than we were about a century ago. There have been some trends during that time, but it's the warmest we have in basically our recorded history. Precipitation, as I mentioned, is a little bit different story, and Michigan, the entire region, and actually extending eastward into the Northeast, these are areas that have become progressively warmer, especially in the last few decades, and that trend shows no signs of abating. We set a new all-time record for Michigan on average in 2019. There have been, and you might say, well, is it seasonal? There is some seasonality to our precipitation, but all the seasons are getting wetter, and it's coming. We have about 10 to 15% more precipitation on average now than we did just 50 years ago. And one way of thinking about that is we could use a wet month, one of our summer months. We have more water and more precipitation in the warm season, but we have an extra month's worth of precipitation on average, 3-4 inches more now than we did on average, again, just 50 years ago. That's a lot of water, and it has made a difference. There have been impacts on the landscape because of that. It's coming both because of more days with precipitation, so more wet days, but it's also occurring because of more precipitation per event, particularly heavy precipitation events. And we have seen a large number of those, an increase in some of our extreme events. And again, we can list off a number of them. We've had flooding in the Detroit area here, more than 20 inches of rain since late June. I measured in Hazlet at my house 5.35 inches of rain in just 6 hours. Back in August, which was by far the most I've ever measured at that location, and it's probably about a 1 in 100 year event on average. We had major catastrophic flooding in the Midland area that was linked with heavy precipitation in east central and northeastern lower Michigan here back in May of 2020. I mentioned the 2019. We set an all-time new record for 24-hour precipitation total up in Mason County here back in July of 2018 with a new record just under 13 inches. And the record before that had stood from Bloomingdale, Michigan back in 1914, and the old record was just under 10 inches. So not only did we break the record, but we shattered it. And we had the Father's Day flooding event in the Keweenaw Peninsula, and it goes on and on. These large events, not only are they increasing in both frequency and intensity, but the impacts are just as large or even larger than they've been in the past. So that's a major, I think, in terms of maybe the most important trend related to climate and weather that we see. That probably is at the top of the list, the heavy rain and flooding.
And those extremes, Jeff, you mentioned that word extremes, and I guess are they going to get more extreme?
That unfortunately is projected to continue, and it is important to note that we do have projections for the future. They are that. They're the best science that we have, and they have a lot of there are challenges to do that. It's a difficult thing, but they're better than they were in the past. And I think the important thing is that projections that were made 10 years ago and even longer than that are pretty consistent with what we've observed, and that's we're on a warmer and wetter trajectory. And unfortunately, most of these projections call for an increase in extremes. As the air temperatures warm, the air can hold more water vapor, which is the raw material for precipitation. And when that happens, at least the potential is there to have heavier rain and heavier precipitation. And that's definitely what we're seeing here. Now, it is also, I think, critical and important to note, there are many places in the subtropical areas and in the western U.S., as close as that, where we have seen even larger increases in temperature, in some cases 4 or 5 degree warming in the last several decades, but it's also dried out. And so there are areas where it's warmer and drier. We're an area that at least fortunately is warmer and wetter, so some of the impacts associated with those warmer temperatures are less than what they would be otherwise.
This is MSU Today. I'm Russ White, catching up with Michigan State University Professor of Geography, Jeff Andresen, to discuss all things related to climate change. And Jeff, you did mention the IPCC earlier. That's the Intergovernmental Panel on Climate Change, out recently with a pretty big report. What's in it?
Right. Well, we are looking at a new assessment from the IPCC. It's going to be the 6th assessment. It's been over 8 years since the last one was released, and it's, again, time for another one. But one of the first major, mile markers just prior to the release of the official report, which is next year, came out here in August. And basically, it was from the Working Group 1, which is responsible for looking at basically climate science and what's new, what's changed. And from this report, it's in its near final form, basically said that, concluded that the warming that's taken place here is probably more rapid than had been observed before. The projections for the future are a little bit warmer than they have been in the past, and the language in the report was more deterministic, certainly more concerning, and the link with human activity and the observed warming that's taken place here over the last century. It's again, the word unequivocal is used. It's happening, and a significant portion, and most of the warming is attributed to or associated with human activities, notably of course, greenhouse gas emissions. And something is going to have to be done, otherwise we risk, again, major problems that will get, the more the change, the more difficult the problems will be to deal with. And so some of the questions are, how can we keep the warming that's already occurred, and it's already over 1 degree Celsius. The hope is to try to limit it, ideally, to about 1.5 degrees Celsius, so somewhere on the order of 3 degrees Fahrenheit by the middle or latter part of the century, and if at all possible, to stay below 2 degrees Celsius, so about 3.5 Fahrenheit. And the rationale there is that once you get out to that level of warming, you risk other potential related problems that could be even worse, so-called tipping points. And so the hope is that if the warming can be limited to under 2 degrees, that we can avoid those, or at least make those less likely. They're low probability, but still really difficult situations to be in, and it's really almost like a laboratory experiment with a sample size of 1 here with our planet. That's should concern everybody. We don't have any other samples or any other planets to go to. We have this one and we have to use it or take care of it. So it's a lot of the same messages as before in this new report, but the certainty with some of the projections and so forth is higher. And again, the language has been ramped up. There's more on precipitation, more on regional impacts than there has been. It's a global, worldwide type of effort, so it's a little unique in that way. But it's the best, I think, overall resource that we have for looking at climate. Literally thousands of people work on this from around the world in a cycle, and it collects all of certainly the best and the most recent research that we have, and to try and make sense out of and consensus, and to help people, to provide information, hopefully, for people to both to educate themselves and also make decisions. So all those things are important. We all need to look at this and know what do we know. And this is arguably about the best resource for that.
Jeff, how in particular is climate change impacting agriculture, certainly in Michigan and beyond?
Well, it's agriculture here. It depends greatly on the crop and on the type of agriculture, and because there's all sorts of impacts. Some of them are negative, and some of them are positive. And one I can think of right off the bat that most people would probably a couple things. One, it's getting wetter, and so if we look for most crops that are grown without irrigation, and this is true not just here in the Midwest, but around the world, the biggest limitation each year is either the lack of or the abundance of water, and have the crop having enough water to get through the growing season. And that accounts for a lot of these changes from year to year. And that's definitely true in the Midwest. But because we have more precipitation, we're less likely on average to run out. It doesn't mean we don't have droughts. We still do. We saw one earlier this year, actually. But statistically, they're less frequent and a little bit less severe than they have been in the past because of that extra precip. So that's a positive. But you can also look at, there's too much of a good thing. We look back to 2019, and we had one of the wettest springs on record. Because of the conditions that left, nobody could plant crops. We had a record amount of agricultural land left idled in the spring with no crop at all because it wasn't possible. And for the crop that was planted and got through the growing season, we then had one of the wettest falls. And so trying to harvest it was a really difficult endeavor. And so we got hit on both sides. And so again, there's always that two edges or ways of looking at things. Another one that's, I think, important is that the timing of the last freeze of the spring season, and here in East Lansing, that typically occurs in early May. We see the climatologically, statistically, last 32 or lower, and that is getting earlier in the season, so it's advancing. While at the same time, our first freezing temperatures of the fall, and we're coming up on that here now in East Lansing, that's the first few days of October on average, that's getting later. It's not every year, but that's the longer-term trend. And we see this all over Michigan and all over the upper Midwest, and it's not insignificant. So that frost-free period that's in between, that last freeze of the spring and first freeze of the fall, it's now at least a week and a half, some cases more than 2 weeks longer than it was just 3 or 4 decades ago. So we have a longer season. And for some crops and for some applications, that's a really good thing, but it can also be a negative. We have pests that we haven't dealt with before, and when we don't have cold weather or cold winters, some of them survive and cause problems that they haven't caused before. So there's always a number of pieces of this, and depending on the crop. But we still have, I think, the important thing for food production or for water, for agriculture here, we have water. And again, we could have argued about that in June, thinking about the dryness, but overall we're blessed. Our climate and so forth is still favorable, and as it gets warmer and wetter, we've seen an expansion of some agriculture farther north, both in the state and in the region. Part of the Corn Belt now is nationally has moved up into the northern Great Plains and even into southern Canada. And 30 years ago, that wasn't the case. So we can see examples of it around us as the climate does shift in other places as well.
Well, Jeff, you mentioned wetter. How about our precious Great Lakes? How are they dealing with climate change?
Well, that's also, again, it depends on the timing, and there's obviously some real concern about this. We look at this wonderful resource that we have around us, and we have literally gone from some of the lowest lake levels as recently as the end of 2013 to some of the highest lake levels in just a few years. And some of these are associated with this trend in heavy precipitation that I mentioned. But we also had 2 of the back-to-back most severe winters. People remember 2013-14 and 2014-15. Those are the coldest winters we'd had in Michigan back-to-back in over 100 years. I had to go back to 1911 and 12 to see something similar like that. And because of that, we had both heavy ice cover on the Great Lakes, but a long duration of ice cover, and that acts to basically inhibit or reduce the amount of evaporative losses we have. And those lake levels are a direct result of the water coming into the basin through precipitation, and then that leaving, which is evaporation. So if you reduce the evaporation, you're going to add more and more water that's not evaporating, and that was one of the keys to seeing why this increase occurred. But the real concern is the variability. And yes, the lakes went from really low to really high, but the variability is a very difficult thing to work with for our communities that are near the lakes. And of course, by the time the levels reached, near record levels here back in 2019 or so, anytime the wind picked up, and if the wind was blowing onshore, we had flooding. And so we have seen we've seen major damage in infrastructure. We've had houses literally fall into the water, but major economic impact from these high lake levels over the last couple of years. Fortunately, it is now the lake levels have gone back down. They're still above normal, but they're certainly not nearly as bad as they were a year ago. And that's some of that is the drought earlier this year that helped with that. And we've also had some open winters with less ice. But again, the issue is is the variability changing? And I don't think there's an answer on that yet, but it's a very important one in terms of how we as society, how we manage this, the risk associated with it. But the lakes are, again, they're a very, very important part of our culture and identity, et cetera, and it's important. They play a major role. The projections for the future don't give us as much, I think, of an insight into where they may be headed. The most recent projections are really not much of a change, or some show minor increases. Some of the projections for the distant future show minor decreases. It depends. So there isn't one clear direction one way or the other, but and it's not easy to do that projection relative to where the climate models come from. So, but the recent activity and the recent high variability has certainly got everyone's attention, and a lot more research is needed on, I think.
Well, Jeff, I mentioned earlier there was a recent United Nations summit on climate, and there's the one in Scotland coming up in November. Are you confident that the world is up to this challenge and the world leaders?
Right, that's a really important question, and we've recently, there was a UN or a meeting at the UN to talk about the upcoming the Conference of Parties 26, and it's a yearly meeting organized by the United Nations to basically deal with the framework on climate change. We've been doing this for about over 20 years now. Last year was canceled because of COVID, but this is a redo for Glasgow and the UK, who's hosting it this year. But the idea here is to come up with so-called determined reductions in emissions by each nation, and how to contribute. One of the major assumptions here, and I mentioned the 1.5 degree and the 2 degree warming, and one of the reverse pieces of the science is that we know that if we want to stay within that range, that emissions, greenhouse gas emissions, are going to have to be reduced by probably almost a half by the time we get to 2030 if we want to make that. And we need to be carbon neutral. That is basically no net gains by the middle of the century. So that's a heavy lift, big deal. And then the question is, for each country, what can you do in terms of meeting these very, very important but very challenging goals? And so each country, there are 180 odd or 190, I'm not sure the total number here, signatories. This goes back to the Paris Accord agreement that have agreed we will find a way to make these reductions. And the U.S., I believe, for the upcoming COP26, a reduction of around 50 to 52% in emissions relative to the year 2005. That would take place by 2030. So again, trying to meet that half reduction in greenhouse gases. There are many countries have already committed. I believe the number's up to 80 or 90 that have already said we're going to do it. Some have even pledged higher than half. And so the intentions are there. Whether that can be done or not, of course, is another question. There's certainly new and encouraging technologies that will help with this, but there are several pieces of this puzzle too, or this challenge. And one, we've talked about the emissions. We need to reduce the emissions. Secondly, we need to, if at all possible, we're going to have to take some of the existing gases out of the atmosphere and fix those. So sequestration and mitigation, that's a big part. That is a challenging one, and there are people working on schemes to do that. But the third one is basically a no-brainer, but it's a necessity, and that's we have to find ways to adapt or cope with the changes that are already occurring, and they are, and more will come in the future. And one of the major pieces of this with this COP26 is the issue of, how do we help countries with fewer resources, lesser developed places in the parts of the world who just don't have the capital or the financial resources to do this. And the hope is that some of the developed countries, like the United States, will help with this, at least in terms of financial backing and supply both money and technology so that these countries can also make these pledges even if they lack some of their own resources. But that's ways of adapting, and there are a number of reasons we need to do that. And one is that the changes in climate, especially the negative impacts, lead to people leaving, migrations, and we've already seen evidence of that in a number of parts of the world, many parts of the world, and political upheaval. It's all linked, and some of it directly, some of it less directly, but it plays a role in many things. And so that's why there's so much interest in this. And again, at this upcoming summit coming up later this fall in Scotland, hopefully new framework, some new goals that are meetable, and then what really is needed, though, are the countries to show the real progress and show, yes, we've made progress in reducing our emissions by X percent, and we have the technology. Here's the plans to do this.
That's MSU Professor of Geography, Jeff Andresen. We've been discussing all things climate. And, Jeff, just some closing thoughts on, leave us with some takeaways.
Well, one is, I guess, we just need to look around us, and there has been there's been ample evidence around us of extremes and challenges and impacts, and this whole issue of a changing climate, it hasn't been at the forefront or at the top of people's lists of issues. We have many issues that challenge us as a society, but climate change, unfortunately, I think is getting higher up on the list, and unfortunately, we really can't afford to wait much longer. Something is going to have to be done, and we have to come up with some plans and some action. There are a lot of good intentions, but we really need to act on some of these. I think the stakes are very, very high, and time is an important part of this. And the good news is, and the glass half full, is that humans have been very good at coping and adapting with changes in the long-term distant history, and there's no question that they can do it again. We have the right stuff and to do this, but decisions have to be made, plans have to be made, and really have to be followed. And that isn't so easy sometimes. But this issue is not going away, and as we've seen recently, it's actually becoming more visible. And so rather than take all of the impacts, many of them negative, and dealing with those, it's easier, I think, to plan. We have to think about those who come after us as well, and their lives, and again, come up with some strategies and solutions to change or to solve the problem.
Thank you very much, Jeff Andresen, Professor of Geography at Michigan State University. I'm Russ White. This is MSU Today.